Dun, 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 dun. Woo! Shit. All right, all right, all right. Awesome stuff, ladies and gentlemen. So, for today, I thought let's actually get into learning unit 2. Let's actually get into learning unit 2. And then we'll just do one exercise in the second session. No. These slides are not long. These slides are. We're going to finish this in the first session. These ones are not. How's everybody doing? Are you guys good? Okay. Right. So learning unit 2 is cost classification and estimation and behavior. Behavior. Now you see why I had the lights off, because you weren't going to be able to see so clear. Right. So cost behavior analysis, all right? It involves separating mixed costs into their variable and fixed components and analyzing how costs and revenues react to varying levels of activity. So this concept here is not all that new, because we did touch on this in last semester in Finance 2A, okay? But we do extend it in certain aspects, right? And with certain concepts. All right, so here, cost estimation involves measuring past costs to predict future costs for decision-making purposes. Okay, cost classification involves grouping costs. All right, in other words, costs that are similar, we then obviously group together to say these are fixed costs, these are variable costs, and here it says according to their common characteristics. Okay, so this isn't brand new. All right, so here identity, is it materials that we're looking at, is it labor, what are we actually discussing? Okay, then function, how do these costs function or behave, or where do they yield from? Does it make sense? Then variability. All right, here remember we spoke on, does the cost vary with our output or not? All right, and that's how we distinguish whether something was fixed or variable. Okay, then controllable and uncontrollable. All right, some costs just spring out of nowhere, unforeseen. All right, then we have normal and abnormal. Remember when we spoke last semester on abnormal and normal spillage? Normal spillage we anticipate, and abnormal spillage, it was a disaster that took place and there was nothing we could do about it. All right, and obviously abnormal spillage is something that it doesn't happen frequently, okay, but yeah, it can happen because there's always uncertainty when it comes to the future. Then time, all right, is it historic or predetermined? Okay, in other words, is this a cost that we've had in the past, or is it one we know we are anticipating is going to be realized? Yeah. All right, so there you can see nothing new on that table right there. You've got your variable costs, you've got your fixed costs, mixed costs. All right, we do know that there are some that are mixed, such as your semi-fixed, okay? Which here, this is just a recap. There's a fixed portion, it's fixed until you step into a higher level of activity, or should I say activity reaches upper or lower levels. Okay, so yeah, you can think of your telephone bill, maybe, for example. No, not telephone bill. I'd actually use logistics. And if we're to lease, let's say, trucks, right? They will lease them to us and they'll say, you only need to pay this amount, assuming you cover this amount of kilometers. If you cover more kilometers, then obviously the fixed cost that will be charged on the lease will then increase, all right, or decrease if you travel less. Okay. I don't know if that actually happens in the industry, but I just thought that would be a good way to explain it. Okay. All right. Then we've got semi-variable. Okay. Costs that respond less proportionately to changes in the level of production output. Production output. Okay. All right. So if you open your textbooks, I think this is actually page 54, I think it might be. 55. 55. With the graphs. With the graphs. Can somebody just shut the door? If people walk in, it's perfectly fine, but meet and greet, no. No. You guys are crazy. All right. Why am I flipping to 60 something? You said 54, ne? 50, 55, yes. Yes, that's exactly what I wanted us to look at. So there you can see. Know these graphs. You need to know these graphs or answering questions? I haven't seen them ask this, but it's been a while since I lectured this module. It's been a while. The last time I lectured this module, I don't even know. No, I'm joking. And a little bit, I'd say maybe 2019. 2019. 2020, yes. In COVID, I did lecture it. So maybe 2021 was the last time I may have lectured it. According to your YouTube channel, yes? Yeah, I guess. I guess. All right. So, thank you, sir. Like and subscribe. All right. So there you can see the different types of costs. There they're giving you also a key that shows you graphically the different costs that we just looked through here on the table, what they would look like from a graph perspective. Yeah, but I don't think they would just ask this. They would, if they ask this, they would ask it in conjunction with other things. Does that make sense? Because this, I think, would be rather easy. Rather easy. Okay, then the next thing we want to talk about is this thing called the high-low method. And now the high-low method is our way of identifying or estimating the fixed and the variable elements of a mixed cost. So you're given a certain cost, and then they'll tell you that at this level of output, this is the total cost that we incur as a result of this. All right? Usually you can think of this as maybe production costs. I think that's the easiest way to think of it. All right? Our costs in production. But it could be applied to other things as well. All right? Maybe even for telephone bill, for example. All right? You know that it's a mixed cost. So at another level, they'll give you the total cost as well. Now you know that there's a fixed portion and you know there's a variable portion to this cost, but you don't know what the fixed portion is and what the variable cost portion is. So this high-low method allows us to calculate what is the fixed portion and what is the variable portion. Now on the projector now, you can see a formula that I believe is familiar with most of us here. All right. What's the name of this formula? Yes, it's a formula we use to calculate a straight line, but there's an actual name for it. Yes, linear regression. Okay. So here you can see A would obviously be your fixed cost. And then obviously your variable component would be B. And can you see X would then obviously be your number of units. And then obviously Y would be your total cost. So obviously our variable cost, right, will depend on how many units we have produced. Does that make sense? And then the fixed is fixed. It's going to remain the same cost regardless of how many units we produce. And then obviously, depending on how many units we produce, plus our fixed cost, we get our total cost. Okay? So we can use this, and we will see how we use this maybe next week sometime. I don't think we'll delve into this week. No, we won't. We won't. Okay, so least squares regression method. It's the same thing. All right, and here they're just highlighting that it's a statistical method. All right, used to study trends and relationships. Guys, believe it or not, we are still using this thing even at a master's level. So if you guys have aspirations in finance, you are bound to probably see this as you further your studies. Okay? So get used to it. And I know you guys have seen this in stats, ne? Yeah. So yeah, you should be comfortable with this. Okay. The whole concept of linear regression or least squares regression method is we know we have different data points, right? Maybe let me just draw an example. Okay. Now it's opening up other things. All right, so you know you have different variables. These are dots. Hey, very strange dots, I know, but yeah, anyway. So this is going to be your output, number of units, isn't? And why this is going to be your total cost. Let me just put TC here. And this is your units. So when we're doing the regression, we're trying to find a line, right, that helps us establish the nature of the relationship, all right? And we know B is the gradient of this line, okay? Am I saying things that sound familiar? Okay, anyway, so this is what they're talking to on that slide. I won't go too deep into this stuff, all right? Essentially, what the method aims to do is to plot the best fit line based on the data points provided. Okay, that's all that we are really doing here. And you guys know how to do this with your calculators. Do you know how to calculate? Because the objective is obviously to calculate B and to calculate A. Does that make sense? Because X is number of units. So obviously we'll just get that out of the question. Y, again, we'll get out of the question. They'll tell you for X number of units, you're going to have a cost of so much. For, let's just call it this level of units, you'll get this cost, okay? And then obviously from those 2 points, you figure out your line, okay? So the objective again is to get your fixed cost and your variable cost, okay? Right, anyway, let's proceed. Okay, so I don't think I need to get into this. I think I've spoken quite a bit about this, but there's an example there in your textbooks, 2.3. Okay, but it's good to know that you are familiar with it. That means that we shouldn't have too many challenges. Okay, the next thing, still speaking to linear regression, test of reliability. The first one that we have there is the coefficient of determination. Whew. Some deep stuff going on over here. Anybody want to tell me what is this thing? What is this thing? What is this thing? I'm not sure, like the variation between like y and x, the extent of the relationship. You could say that, yes. Here they say measures the percentage variation, which is what you said, in the dependent variable that is explained or explainable by the variations in the independent variable. All right, how reliable, all right, is the relationship? That's what we are pretty much looking at, okay? So we're basically saying how reliable, all right, whatever we've gotten, whatever we've managed to produce, we're asking how reliable is this? Because the number of units is independent and your total cost is the dependent. How reliable is the number of units in explaining the variation of our total cost? Is it a good explanation for when units increase, can we reliably say yes, our total cost is also going to increase? That's what they're speaking to there. So how do we gauge the goodness of fit? we say if this coefficient of determination, all right, the closer it is to 1, the better the goodness of fit, the better, the more reliable this thing is. Okay? Okay? Right. Then, okay, so this is just going on. Huh? It says a ratio of 1 would be a perfect fit. All right? Or the variation in the dependent variable is explained by the variation in the independent variable. Okay? So, in other words, it is a very good predictor of how the dependent variable, in this case, we're talking total sales, will behave when it, and then here, very important, 0.30 or higher is a good fit. Okay, 0.30 or higher is a good fit. Right, and then there's the formula. I have not seen them ask this too much. No, I have not. But usually they ask you to explain, what does this coefficient of determination mean? What does this, so this one, the next one we have the standard error of estimate. So usually they want you to define them, but I have never seen them ask in finance to actually do the calculation and stuff. Okay, so standard error of estimate. There, what are we looking at? It provides an indication of the absolute size of probable deviation from the line, or the extent of dispersion around the mean. Okay, I actually want to duplicate this slide here, copy, and then let's see if we can paste it where we are. Where were we? Uh-oh. Let's see. All right. So this line, it's a mean. It's an average. We are estimating. Does that make sense? It's not precise. So there is going to be a deviation. So if we say, if we have 10 units, if we produce 10 units, we would have said, according to our graph, we should have a total cost of, let's just call it 10,000. That is what we predicted or forecasted, but it's an estimate. We might, in actuality or in reality, we might actually find out that our total cost is 10,250. Can you see that? So here now, when we're looking at the standard error of estimate, we're saying, what's the deviation like, roughly? Does that make sense? Is it making sense? How far off could we veer from the mean or from the line that we've obviously put together? Okay, and there's your formula there. Anyway, let me not spend too much time on them things because, all right, you just need to kind of understand it. All right, standard error of coefficient. Okay, so here we're checking the reliability of the estimate of the regression coefficient of B, whether a relationship between the independent and dependent variable exists. Okay, does it exist? Okay, greater than 2 usually represents a significant relationship between the variables. And there you've got your formula. Okay.
This is also like the coefficient of determination where they also like ask us to calculate more or less, but they'll ask us to like comment.
Yeah, all three of those. Usually they just ask you to define. Okay. Yeah, you would rather be safe than sorry and know how to calculate them. But yeah, I've never seen them actually ask you guys to do it. No. Oh yeah. Actually, it is. This is unit 2. Yeah. No, test 1. I feel very confident you guys will be fine for test 1. No one's. I'm gonna pretend like I didn't hear the question. No, you guys will be fine. I think you'll be fine even test 2, but yeah, it's going to just require a lot of you just to practice. That's all. Okay. So here now they're just talking about the advantages. It's a statistical method which is preferred to subjective methods. Subjective things is just an opinion. When you think subjective, it's an opinion. So here we actually have something that gives us some sort of indication. Is there a relationship? What type of relationship is there? Okay. And then obviously just allows us to begin to make relevant estimations. So that's what they're speaking to there. Accounts for all available observations and provides more accurate results or output than the high-low method. Okay, then there's quite a few disadvantages. Data used for cost estimation is not representative of the population. All right. We take a sample of the data points. We don't usually put all data points. Does that make sense? Because then that would be a lot for us to obviously analyze. Okay. Then effects of inflation are not accounted for. Remember, we look at previous data, right? So if inflation now takes place outside of that previous data, we obviously would not have accounted for that. Does that make sense? And even when we want to now make forecasts, to say our costs are going to be 10,000, right? Inflation might have happened. And then obviously our cost might actually be 10,500 or even 12. Does that make sense? Because the cost per unit has increased as a result of inflation. So that's what they're speaking to there. Historical data is used to estimate future costs. We've already pretty much spoken to that. Okay. Cost estimation and forecasting can only be done within a given range of activity. Okay. Within a given range of activity. Okay. Then lastly, there is an assumption that there are only two variables involved in determining cost. If more than one variable is identified, multiple regression analysis will need to be used. Okay. And now, when there's more than one variable under analysis, sometimes you might feel you're forgetting other variables. Okay, does that make sense? Right. So it can be tricky once you start stepping into multiple linear regression or multiple regression analysis. But yeah, it is definitely doable. So it's not a perfect science. It's definitely not a perfect science. Okay. Now we step on to another important concept here. And this is a concept that, guys, I'm telling you up front, now we're just discussing it. It's very easy to understand theoretically, so don't be alarmed. But it's one that you're going to need to practice to make sure you understand for your test. The learning curve theory. Okay? And basically what we are talking about with the learning curve theory is that, like everything in life, the first time you do it, it's going to be more difficult. It's going to take you more time, right? But as you begin to practice more and more and more, it's going to take you less time. What is happening between the initial time you attempted this task and the point in time where you're taking less time to complete the task? What is actually happening?
You gain more knowledge on how to answer the question in a
faster way?
Or you gain more better understanding of it.
Yes. So in some way, shape, or form, you've become more efficient, right? 100%. Thank you for that. Right? You've become more efficient. You've learned one or two things that obviously accelerate your process. Okay? And that's what the learning curve is all about. It's basically saying that as we produce units, first it might take us 5 minutes to produce the first unit. But in time, it may take us 3 minutes or 2.5 minutes. Okay? Now the learning curve is us mathematically determining how fast we are now being in obviously completing the units. So here it says a learning curve is essentially a measure of the experience gained in production. All right, that's pretty much what Ash was talking about. The rate of learning is specified as a percentage that is related to the average time taken to produce a unit. So that is what you can take away in a nutshell. We're looking at the average time taken to produce a unit. And so what they typically do is they tell you to produce 10 units, how long is it going to take us? You need to calculate the learning curve. To produce 34 units or 62 units, how long is it going to take us? And the more units we have, the more efficient we are going to be as we go along. Does it make sense? So the learning curve is going to be different for those different amounts. The theory suggests that this average time will decrease as the same task is performed repetitively, which is exactly what I'm saying. At a certain point, the learning process will cease and the time taken to complete the task will stabilize. So we can only get so efficient. Does that make sense? At some point, there's no more new knowledge or ability to get more efficient. Does that make sense? Okay, that's all they're saying there. The learning curve or process curve is associated with the rate of learning. Okay. The average cost per unit drops as the quantity produced increases. What are these people saying? Somebody help me. What do they mean by this? You saw that statement there in red underlined? The average cost per unit drops as the quantity produced increases. How?
Because you're yielding a greater profit because you have more units to sell.
It's not about units here, though.
It says
You're right.
cost per unit.
Yes, but it's not. Okay. Say it again. Let me hear you.
So the reason for the average cost decreasing,
Yes.
when the quantity increases,
Uh-huh.
because you have more units to sell. Or, for example, they give you a discount for producing more. I don't know.
I'm still sticking to my answer. Yes, I see your logic, but here we're specifically talking to the learning curve. Yes, sir. What are your thoughts?
The average cost per unit drops as the quantity produced increases because you become more efficient, meaning you spend less money to execute.
What is that thing that you're spending less time on?
Spending less time producing quantities.
Okay.
Since you're more efficient over time.
Yes. That's it. To really contextualize it so you see what I'm saying, all right? We're talking about direct labor, right? Because we're talking about completion of a task. So that direct labor time, what took us maybe let's say 10 hours to do, we're now doing in less time. So remember, we are paying for every direct labor hour. Does that make sense? So as a result of paying less for that, right? We're then saying the cost per unit is going to decrease as a result. Are you now seeing it? Because our direct labor per hour, we're getting more for every hour that we pay. Yes?
This is just a genuine question.
Mm.
Does it also speak like direct materials, for example, like let's say you learn how to use the product better so there's less wastage?
I think you could speak to that. All right. And I must be very clear. What Ash was saying isn't wrong. I was just obviously trying to answer from a learning curve perspective. Does that make sense? Okay. You could potentially apply that. And I think there in that context, you would also then say, you actually mentioned it, wastage, spillage, right? So with less spillage, obviously you're becoming more efficient. So you could apply that, yes.
At what point does it plateau?
Does it what?
Your learning curve plateau.
I don't know. I don't know how exactly. How can I say this? I don't know at what point exactly. It would probably be different for the different processes, but it definitely plateaus for everything. You can only get so good.
So,
Yeah.
to basically summarize, the average cost per unit dropping as the quantity produced increases. Is it because the direct labor became more efficient? That's it.
Yeah. From a learning curve perspective, because as you mentioned, there's many ways that we can reduce that average cost per unit.
Sure.
Yeah. Okay. All right. Cost predictions must allow for the effect of learning and reflect the steady decrease in cost. So this is why we're actually learning the learning curve. Because basically what we are trying to look at, remember we're focused on costs in this learning unit specifically. So we're trying to say what would be better for us. Should we only produce 10,000 units or should we actually produce 20,000 units? Because we might actually begin to realize that, hey, it would be better off for us to produce 20,000 units because the cost of producing 25,000 units is not significantly greater than that of 10. Or maybe let me say 15,000, just to make it a little more practical. Does that make sense? And so we might as well take advantage of that decrease in cost. Okay? So we as financial people need to be able to obviously calculate the learning curve ratio. All right, the rate of learning or the learning curve ratio is calculated on the average time of cumulative production. All right, there's an example there in 2.7, but I think we'll look at this. You guys might get it for homework. I know I'm giving you 2.1 and 2.2. Very short, very short. To do for homework. All right, then there's a different way of calculating the learning curve. There's also the exponential function. Okay, so it's used to calculate the average time with a power model. Okay, we will also see this. If you can understand it, it's actually the easier way. If you can understand it, okay, and then we have to make use of a log function within that formula. Okay, but yeah, we'll get into that when we do exercises. The decrease in production time results in a parallel decrease in costs, as each additional unit entails less labor, more units produced from the same equipment, fewer delays, and lost time. Okay, so that's just a little more meat on what we were discussing earlier. Okay, incremental cost can be derived from calculating the additional hours required to produce such products and multiplying the additional hours with labor rate. The how. The incremental hours can be derived by examining the difference between total hours for various combinations of cumulative hours. Okay, so they are pretty much just saying what I was saying with the illustration, where I was saying, if we look at producing 15,000 units, and if we look at producing 20,000 units, what, from a financial perspective, would be more ideal for us to produce? Where do we get greater benefit ultimately? And ladies and gentlemen, that is your learning unit 2 from a theoretical perspective. From a theoretical perspective. I think we can take a break now. And then when we get back, we'll just quickly do exercise 1.14, and that'll be it for today.